Arduino uses sensors to understand and react to its environment, much like how humans rely on their senses. These components serve as input devices, feeding real-world data into the microcontroller so it can make decisions and take action. For instance, a light sensor detects brightness levels, allowing your project to automatically turn on a light when it gets dark. Buttons or touch sensors detect physical interaction, enabling users to control devices with a simple press or tap. Microphones can pick up sound, allowing Arduino to respond to noise levels or even specific voice commands in more advanced setups. These sensor inputs act as the eyes, ears, and skin of your Arduino project, translating physical changes into data the board can process. Once the data is received, Arduino uses it to trigger outputs, like moving a motor, displaying a message, or changing LED colors. By integrating sensors, your Arduino can interact intelligently with the world around it, responding to light, motion, sound, pressure, temperature, and more. It's the first step toward making projects that are not just automated, but aware. Inputs are like the senses of an Arduino, allowing it to gather information from its environment and respond intelligently. Just as humans rely on sight, touch, and hearing to navigate the world, Arduino uses sensors to detect changes and conditions in its surroundings. A light sensor acts like an eye, detecting brightness levels, helpful for projects that respond to day and night. Buttons and touch sensors serve as a sense of touch, allowing users to trigger actions with a simple press or tap. A microphone works like an ear, capturing sound waves that Arduino can analyze to detect noise levels or respond to specific audio cues. These input devices collect real-time data, which the Arduino then processes using code logic. Based on the input, it decides what output action to perform, turning on a light, sounding a buzzer, or moving a motor. Understanding inputs is the first step in creating interactive and responsive Arduino projects. They bridge the gap between the physical world and the digital brain of your board, making real-world conditions part of your program's logic. Outputs are the actions an Arduino takes after processing input data. If sensors are its senses, outputs are its voice, muscles, and signals, allowing it to interact with the world in meaningful ways. For visual feedback, Arduino can light up an LED, flash a sequence of lights, or display messages on an LCD screen, perfect for alerts or data readouts. To provide sound-based responses, it can activate a buzzer or speaker, creating beeps, tones, or alarms. More dynamic outputs involve movement. Arduino can control motors to drive wheels, open doors, or spin fans. It can also manage servo motors to create precise angular motion, useful for robotic arms, camera mounts, or automated levers. These outputs are driven by logic coded into your sketch. For instance, if a sensor detects low light, the Arduino might turn on an LED. If a button is pressed, it might play a sound or move a motor. By combining inputs and outputs, Arduino projects become truly interactive systems capable of sensing, deciding, and acting, bridging the gap between digital instructions and real-world behavior. Arduino works with two primary types of signals, digital and analog, each with distinct roles in how your project senses and responds to the world. Digital signals are binary, meaning they can only be in one of two states, high, on, or low, off. Think of them like a standard light switch. You're either flipping it on or off, with no in-between. Devices like buttons, limit switches, and LEDs commonly use digital signals for simple, reliable interactions. Analog signals, on the other hand, offer a full range of values. They're more like a dimmer switch, capable of expressing subtle changes in input or output. Sensors such as temperature probes, light sensors, or potentiometers produce analog signals, which Arduino reads using its analog input pins to measure changes in voltage, typically from 0 to 5 volts. Understanding the difference between these signal types is essential for selecting the right components and writing effective code. It determines how data is read, how decisions are made, and how your project behaves in real-world conditions. Arduino projects come to life through the synergy of inputs and outputs. By sensing the environment and responding with action, Arduino enables systems that are not just functional, but interactive and intelligent. In smart home automation, a moisture sensor can detect dry soil and trigger a water pump, automatically keeping plants healthy. This hands-off solution showcases how simple sensor-actuator pairs can handle everyday tasks. In robotics, an ultrasonic sensor measures distance to detect obstacles. The Arduino processes this data and adjusts a motor's direction to steer the robot away, creating machines that navigate spaces with autonomy. For environmental monitoring, a temperature sensor captures ambient heat levels. This data can be displayed in real time on an LCD screen, giving users instant feedback and allowing for tracking over time. These input-output interactions form the core of Arduino innovation. They allow projects to sense, think, and respond, automating processes, enhancing user experience, and turning ideas into engaging, responsive systems. So far, we've explored how Arduino interacts with the world, gathering data through inputs, responding with outputs, and understanding the difference between digital and analog signals. These concepts form the core foundation of Arduino programming and hardware integration. They enable your board to sense real-world conditions, make decisions, and perform tasks that bring your ideas to life. Mastering how to read sensors, control devices, and structure code based on input-output behavior sets you up for more advanced projects. It's not just about blinking lights or turning on motors, it's about understanding how systems communicate and behave logically. Next, we'll take things further by introducing libraries and memory management. These tools simplify more complex operations like connecting to Wi-Fi, displaying graphics, or handling multiple sensors, and help your Arduino run efficiently. With these techniques, you'll be able to expand your project's functionality while keeping your code clean and organized.